All right, good morning, Mount Vernon. I'm going to be doing the practice test for Unit 4. So this is Unit 4, Algebra 2 practice test. All right, so the first one is what is equivalent to this. So every time you have a problem similar to this, number 1, number 2 are kind of the same. Make sure you try to simplify terms that are the same, right? So I know, and if you need like to see it, it's sometimes I do it this way to teach the class. So 4 can be divided by 2, right? A negative 3 by a to the power of 5, b to the power of 4 by b negative 7. So the numbers you can simplify, right? 4 divided by 2 is just going to be 2. So whenever I have a fraction, it's subtraction, right? So a negative 3 minus 5, b 4 minus negative 7. So this end up being positive. So this gives you 2a negative 8, b to the power of 4 plus 7 is 11. So this negative can be positive if I put it as a denominator, right? A to the power of 8 to b 11. So this is, I don't know if this looks like an A. So that's what we need to do. 2 times b to the power of 11, a to the power of 8. All right, number 2 is multiplication. When we do multiply, we add, okay, the exponents. The numbers can be multiplied. So 2 times 5 is 10. But a7 and a negative 3, I'm adding a positive 7 plus negative 3. B squared plus 0. Is that what it is? 0, yeah. And then C doesn't have anything, so C stays. So it's going to be 10. And you can kind of eliminate, like 2/5, or if this is 7, you can eliminate those two, right? 7 plus negative 3, it's going to give you 4, A4. Sorry about that. 10, a to the power of 4, because when I add 7 plus negative 3, it's 4. When I add b2 plus 0, it's just b2, and then c. I shouldn't put any plus sign here, c. So 10, a to the power of 4, b squared, c is going to be your answer. All right, for number 3, it's asking you the length of a rectangular classroom floor is 19 feet less than the twice the width. So they already put the equation in there for you. And then it says which expression represents the area of the classroom. Area of a rectangle is length times width, right? So I know it's going to be, the area is going to be length times, which is 2w minus 19, times the width, which is w. So since it's multiplication, you're multiplying both of them by w. So a is 2w times w is 2w squared minus 19w, because w times 19 is, then that's the one you have to pick. All right, so this one is adding it, right? So 2a plus 3b minus 2c plus 3a. So there's no multiplication, it's all addition. We can only add like terms. So I'm adding 2a with 3a with a. And then none of them are minus. If there was a minus, I have to distribute the minus. So 2 plus 3 plus 1 is 6a, right? Then I have to do 3b minus 4b minus 5b, right? So 3 minus 4 is negative 1. Negative 1 minus 5 is negative 6b. And lastly, we have negative 2c minus c plus 4c. Negative 2c minus c is negative 3c. Negative 3c plus 4 is c is just a c plus c, positive c. Okay, so this one, given the function, which with the domain of all real numbers, find the range. So they're saying the domain with the domain of all real numbers. So the domain is already given to be all real numbers. They want you to find the range. So what I will do is I'll pull my Desmo out and I'm gonna graph it. All right, so I open my Desmos and it's f of x, the cube root of x minus x plus 1. So you got to go to functions, and then the miscellaneous would give you that radical form. So that's going to be 3, right, to write the cube root. And then you're going to put x plus 1. And then outside, you have plus 2. All right, so this is the graph. So I'm just going to make it a little bit bigger so that you guys can see. So they said the range, the domain is all real number, but the range is what? So it looks like it's going this way, right? And it's going up. So it goes in, it goes in a slower pace, but it goes up. There's no limitation, right? It keeps going, but it's in a lower pace. Same thing if I go to the left side, it goes in a y direction, and you can make it smaller. You can see that, like over here, for example, would be like negative 120, negative 2.9, but it's going, okay? That means it has an, both direction, x and y axis going both directions. So let's minimize this and come here. So our choice would be all real numbers, negative 1 to 0, 2 to 0, 1 to 0. So we just saw one of them, right? Like as we were doing it. So you can see, like if I go here, it passes negative, oh, this is 1 point. So let's see, like here, negative 2.79, right? So I know it passes the negative 2.7. So both sides will be all real numbers. Range is also negative infinity to positive infinity. All right, number 6, given the polynomial function below, identify to the nearest tenth the range and the domain of this function. Again, you're going to go to Desmos and plot it. Okay. All right, so I just graphed this, and as you can see, it's going upward, but it has limitation for the range. The domain keeps going. If you go to the right, you see there's always a graph that matches it. If you go to the left, you see there's always a graph that matches it, right? It's just in a slower pace. So the question is, find the range, right? So the range starts from here. So the y coordinate here is negative 6.33, and it going up, right? So you have to pick, so it's not 0. No, it's not, both of them are not real numbers, right? And then here it is, I think A. Because y is greater than or equal to negative 6.33, so it goes up, and domain is going to be all real numbers. Okay. All right, so for the next one, the same thing. Find, given the function f of x, x plus 1, with the domain all real numbers, find the range. So just go ahead and do the same thing here, right? The square root of x plus, so we go to function, square root. I don't need anything here, right? Oh, sorry. I can just put 2. That's what it means, right? X plus 1. X plus 1. See how it has a starting point here and it's going to the right? So the domain has limitation. Therefore, also the range, because the range is 0 and up. The domain is this number and to the right, -1 and to the right. So all real numbers greater than or equal to -1. Yeah, so that -1 is what we have to do. So we'll pick B. Okay, number 8. All right, so this is asking you with the following graph, which appears to be the turning point. So the graph goes up and turn here, right? And then goes down and turn here. Those are your 2 turning points, but they only gave us 1. Is it -2, 0, right? -2, 0 here, and 0. And then here is -1 point something. So I have -2, 0 here, so I'm going to pick that one. They don't have this one, so I don't need to try to find it. All right, something similar graph, but now it says write the intervals which the function is increasing. Remember, we increase as we go up and we decrease as we go down. So from here, as I go up until here, right? And then when I go down, from here to here, I go down, right there. And then I go up again from here, so we go up, okay? So the question is increasing, so I'm looking for the green one, right? From -infinity all the way to -2, right? That's the -2 is the x coordinate. And then from +0.6, I guess, all the way to +infinity. So negative infinity to -2, and then from +6 all the way. So A would be the right answer. All right, so though which of the following intervals only increasing? So again, I have another function. So you just come here, f of x is right there. So I'll put negative parentheses x -1 close parentheses open 1 x -4. You can see that it has multiplicity of 2, right? So increasing is what the question is talking about, right? So if you look at this graph, it's going down. It's going down, 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 down until it gets here. Increase and then down. So the increasing is between 2 and between 4. That's the only place it's going up. The rest is going down, up, down. Okay, so remember, you're going to say, oh, this is up. No, when you go from left to right is what you have to do. When I go left to right, what happened to this graph? It goes down. Left to right, it went up. Left to right, it went down. All right, number 11. The zeros. This is an easy one. So y equals graph it. Everything can be, not everything, but in this case, I can graph it, right? Or sometimes I see my children do this. I don't know if it works here. They try, oh, it doesn't work from Smart Notebook. They try to copy the whole equation and put it in x squared plus x plus 1. So what are your zeros? The zeros are a negative, negative 0.4, 1, and 2.44. All right, the polynomial function has a 0 between which numbers? So the max, so it says between which two numbers? So from -1 all the way to 3. Oh, well, I guess so I have one from negative, so between -4 and -3, do I have a 0? No. So that's going to be, let's just do one at a time. Sometimes it's not asking you which one is the 0. It's just say which one is between, has a 0 between which numbers. Do I have a 0 between those two? No. What about between -2 and -1? No. What about between 0 and -1? Yes. Right? This is between 0 and -1. Let's ask a little bit different. All right? Which best describe a polynomial function of the graph? Is it odd degree, positive leading coefficient, or what? So first thing you do is how many turns it has. It has 1, 2 turns. So it has one more. So it's going to be an odd degree, definitely. Is it going down or is it going up? Since it's going up, it's a positive degree. Right? So it's going to be A. All right, describe the end behavior. So as x approaches negative infinity, this is going up, right? As x approaches positive infinity, it's going down. So negative infinity is positive, yes. Positive is positive, no. Negative is 0, no. So it's got to be A. All right. The zeros of a point, 1/2 and -1. So for -1, so that means if I put -1 here, and if I put 1/2 here, would that equation be 0? -1 minus 1 is going to be -2, so no. So it can't be a negative number, right? It has to be the opposite number. So for 1/2 to work, it needs to be in here, right? If I take, so if I put -1 plus 1, would that give me 0? Yes, right? So the next one is 2 times 1/2 minus 1, right? The 2 cancel out, so I have 1 minus 1. Would this give me 0? Yes. All right, 15. Which of the following appear to be linear function of the polynomial function? All right. Display on the graph. So you have to look at this, right? These are your three things. So I have -1, -1. Oh, you know what is easy? So I know it's gonna be, so it's either, because I know one of them is gonna be, well, let's see, I don't know anything. So let's just graph this, right? Open a parentheses, x minus 2. I mean, there's a way to do it by hand, but just 2, close parentheses, open a parentheses, 3x plus 1. Is that the same graph? No, right? So now you're going to do, you know, that's not the same graph, so A is not working. Sorry, let's try B. I should have muted my mic, but just came 2x minus 1, close parentheses, open a parentheses, x squared minus 4x plus 3, and close parentheses. So let's delete this one. Is this the same graph? Huh? It looks like it, right? 0.5, negative 4.6, right? And then that. Only thing is this is close to the 4, the 5. So it looks like for B, but just let's make sure. So I'll say B, but let's check C. So x minus 1, open a parentheses, x plus 3 plus 3. All right, so I plotted both of them, C and D. So C is the block one, so definitely C is not working, right? So now let's see. This is -1, it looks like it. 0.5 and 3, yeah, it's going to be D. Because B is close, but this one wasn't correct. This one is not 4 point something. So D would be, that was a tricky one. Okay. All right, so which graph best represent the function? -2, -1, 2. So it needs to go through the graph there. -2, +1. Oh no, I wanted -2. Oh, my BD. Yep, -2, -1, 2. So it's going to be this graph, D. And 17 and 18, is there 19 and 20? Okay, I'm running out of time. All right, I don't want my thing to be more than 20 minutes. So what is the remainder when you divide the following expression? So there you go. All right, so this question is asking what's the remainder when you divide the following expression, right? So you can do it in any way. Synthetic division is better for you. You can do synthetic, or if you want to just do long division. So I'm usually a long division person because that's what I grew up with, right? So -x³ plus 2x squared plus 5x minus 8, right? And then this is x minus 2. So once you write it down, remember, you take the first coefficient, so -x³, and then divided by x. Whatever you get is going to be your numerator that your divisor that you're going to put here. So x³ divided by x gives you -x², right? So I put -x² here. Then I multiply. -x² times x is going to give you -x³. -x² times -2 is positive 2x². Now we're going to subtract. -x³ minus minus becomes positive. This cancel out. 2x² minus minus 2x is going to be 0, right? This is going to be -2x 0. So 5 comes down, right? 5x minus 8 comes down. So I'll take the 5x divided by x. I'll have 5, positive 5, because the x cancel out. So 5 times x is 5x. 5 times -8 is -10, right? 5 times -2. So now you subtract. 5x minus 5x is 0. -8 minus -10 is just going to be positive 2. So the question is, what is the remainder, right? The remainder is 2, and when you write it as a fraction, you write it as remainder 2 over x minus 2, whatever this is, right? So 2 over x minus 2 is what you guys gonna pick. All right, any question for this one? No? Okay. We can do this with synthetic division just to kind of help us, right? So the first thing is I need to set this equal to 0 so that I know what my divisor is. So -2 minus 2, this is going to be -2. And all I have to do is take the coefficient of each number. 3, 2, 1, 0. So I don't have, I didn't skip any. So 1, 7, 14, and 8. That's my synthetic division, right? So now you're going to draw your line, and you bring the first one down, which is 1. 1 times -2, -2. Now you add. 7 minus 2 is 5, right? 5 times -2 is -10. 14 plus negative 10 is negative, no, positive actually, right? It's positive, because 14 is the larger number. 14 plus negative 10 is 4. Yeah, oh, thank you. 4 times negative 2 is negative 8 plus 0, right? So this is a remainder. This is x to the power of 0. This is x to the power of 1, and this is x to the power of 2. So when I write it, or n in this case, right? This is n, and then this is your remainder. So when I write it, this is going to be n squared plus 5n1 plus 4. Easily, this would be A. Okay. All right, number 19. So we wanted to factor this, right? What's the factor of x squared minus 70x minus 60? Remember, this is the number you're looking at. I have to look at, when I multiply a times b, that needs to give me negative 60. But when I add it, it needs to give me the middle number, which is negative 7. The good thing is they already gave you the numbers here, right? You just have to figure out which one. So, and when I add it, if it needs to be positive, right? Negative, I'm sorry, then that means my larger number needs to be negative. So is it between negative 12 times positive 5? So I know it's not going to be this one, right? Because I need it to be. Or is it between negative 15 positive 4 times positive 4? So you want to get the number negative 7 out of this, right? This gives you negative 11, right? Negative 15 plus 4 gives you negative 11. Negative 12 times 5 gives you negative 7. So the answer, easily you can see it. It gives you that one. All right. So if you want to use decimals, what you can do is you can graph this and put this. If they match, then that's the answer. That's also another way of doing it. All right, the last one. How many complex solutions does the given equation have? Does it have choice? Oh, this one. It does have a choice, right? It's just I couldn't, the boxes, right? I think it's 1, 2, 3, 4 is the choice. I don't know. So, but just let's graph it. Where's my decimal was here? All right, side by side, my equation. So it's going to be x to the power of 5, right? Minus 5x cubed minus 0, 1, okay, minus 36x, right? So that's what you have to do. So how many do we have? So I have a solution 1, 2, 3. So we pick, I said, yeah, so 3 is what we're gonna pick. Wherever the 3 is, I don't know.